In the evolving landscape of modern warfare, the integration of technology and robotics has opened a new chapter. The recent developments on the battlefields of Ukraine have highlighted the innovative use of unmanned ground vehicles, UGVs, equipped with advanced electronic warfare, EW, systems. These robotic platforms, designed to suppress enemy drones, are a testament to the changing face of combat operations. The Triton EW system, developed by laboratory PPSH, is at the forefront of this technological advancement. Mounted on the robust Varan UGV, the Triton system is engineered to create a shield of electromagnetic interference, effectively neutralizing the threat posed by aerial drones. This system is not just a defensive measure but also a strategic tool that provides cover for evacuation teams and mine-laying robots, ensuring the safety of personnel in no man's land. The effectiveness of the Triton system against both FPV drones and bomber drones carrying explosives has been emphasized by Denis Oslomyenko, CEO of Laboratory PPSH. With the capability to disrupt the operation of suicide action drones and those carrying droppable explosives, the Triton system is a critical component in the arsenal of the Russian invasion forces. As the conflict unfolds, the Russian forces continue to innovate, developing new concepts of UGVs that can accompany assault groups or special assault robots. These new models, equipped with the Triton jamming system, are expected to become a common sight in the future. The current models, already operational in the SVO zone, demonstrate the practical application of these EW robots. The versatility of the Triton system is further exemplified by its different versions, specifically designed for deployment on ground drones. The LGSH-608 and LGSH-609 modules are integral to the system's ability to create interference, showcasing the Russian forces' commitment to diversifying their EW capabilities. In response to these advancements, Ukrainian forces are not standing idle. They have developed countermeasures that enable FPV drones to operate effectively, even under enemy electronic suppression. The implementation of machine vision technology has allowed Ukrainian drones to continue their missions and destroy targets, despite the presence of Russian EW systems. As the war continues, the ingenuity of both sides in leveraging technology for tactical advantage is a stark reminder of the ever-changing nature of modern warfare. The Triton system, with its potential to be mounted on various UGVs, represents a significant step forward in the use of robotics in combat scenarios. The ongoing development of these systems and the countermeasures employed by Ukrainian forces will undoubtedly influence the strategies and outcomes of future conflicts.